value of phi be n, your value will be in pound. Why pound? Because you use 4,000 pound per square inch. Your F yield pound per square inch. Everything in pound, everything in inch. So your final design axial load will be in pound. You can divide it by 1,000 to make it in kips. Very simple design. Very simple design. Because everything is given. Yeah, go ahead.
Why is phi 0.65?
Because your column is tight column. According to ACI, phi equal 0.65 for tight column. Maybe equal 0.75 for spiral column. Different value. 0.7. This example is very simple because everything is given. Your column dimension is given, your steel reinforcement is given. Just you are using the equation for design. That's all. So this column with these dimensions and this steel reinforcement can only support this force. So if you would like to make some design, your reaction from structural analysis or from RISA on this column must be smaller than or equal this number of design. This is our design philosophy. One more example. Let's do one more example. For the short square tight column, this column is a square. Square. What does it mean? Square. Because in the exam, someone will say, hey, the second dimension not given. That's right? So what's the second dimension? 18, because your column is a square. A square means this distance equal to this distance. Read your problem carefully. The applied axial dead load 150. Dead load. The reaction dead load equal 150. The reaction life load 250 kb. Fc prime, F yield is given, assuming that the longitudinal reinforced bar are all the same size. What is the minimum required size of each longitudinal reinforcing bar? How many bars do you have?
8 bars.
8 bars. What is the size of each bar? We need to figure it out. Okay. Short column, yes. Tight column, yes. Your design equation phi B N equal 0.8 phi 0.85 Fc prime area gross minus area steel plus area plus F yield area steel. Do you agree? This value of your design will be 1.2 dead load plus 1.6 live load. I will design according to the given load. 1.2, 150, 1.6 time 250. Phi for tight column equal 0.65. Fc prime is given. Be careful. Be careful. This side of equation in units of kips. Because 150, 250 in kips. So what do you think? Keep everything in kips, okay? So Fc prime, which is 4,000, will be 4 kip per square inch. Area gross. What is the area gross of your cross section? 18 times 18. What is the area steel? 8 times something. 8 bar, but the cross section area for 1 bar, I don't know, because I don't know what is the size of the bar. That's right? F yield 60 to be kept per square inch. Area steel equal 8 bar times something. Do you agree? How many unknowns do you have in this equation?
1.
Something. This something. Only one unknown. So, area of 1 bar equal, you can get it, because there's something called area of 1 bar. Type 8, you can get your area steel. Once you get area of 1 bar, go ahead and open your table. Based on the area of 1 bar, I can decide which size I can use. Number 5, number 6, number 8, number 10, whatever. Do you agree? Your
Can we
question.
use the ratio to find the bars?
No. The only equation is given for design is this one. And your percentage of area steel between 1% and 8%. The minimum and the maximum. So I cannot which percent I will use. 1%, 2%, 3%. So I need to put what is required to cover this design. So the best scenario to design your column or to solve the problem of column, to put your equation and see what is given, what is not given. Then go ahead and design your column. One more example. Last one, promise. Design a square tight column to support an axial dead load of 130 and axial life load of 180. Concrete strength for 1000 grade steel grade 60. There is a hint here, say, hey, steel reinforcement not given, cross section not given, nothing is given. The only thing given in this problem from structure analysis, your T ultimate, which is 1.2 dead load plus 1.6 life load. Dead load 130, life load 180. So you can figure out what is the value of your P ultimate. 1.2 times 130 plus 1.6 times 180. Your value 3/4. Kips. 444. Okay, that's fine. I cannot figure out what's going on, but anyway, phi Pn equal 0.8 phi 0.85 Fc prime area gross minus area steel plus F yield times area steel. Do you agree? The problem said, hey, you can assume your steel reinforcement ratio equal 2%. Later, you can choose this percent. So area steel divide area gross equal 0.02, 2%. So your area steel equal 0.02 area gross. Go ahead and put your numbers. Phi Pn, your design load, I will design on 444. Okay. Your Phi 0.65. Fc prime in cap will be 4 K psi. Area gross, I don't know what is the area gross. Area steel, I will remove area steel and put 0.02 area gross plus F yield 60. Area steel 0.02 area gross. Do you agree? How many unknowns do you have? Only one, which is your area gross. Can you get it? Okay. What's the value of area gross? 0.1 minus 0.02 times 0.85 times 4 plus 60 times 0.02 times 0.65 times 0.8 divide 444 188.4 inch square. This one is the area of your cross section of cone. I need to convert this area to 2 dimension. Yes, your column is a square column. So square root for this value can give you, this dimension will be 13.7 inch times 13.7 inch. Please go ahead and round your number to be integer. So I think 14 inch times 14 inch will be good. Hey, can you tell me what is the area steel? Yeah, your area steel will be 2% of this area, 14 times 14. Can you tell me what is the number of bars? Yeah, but first tell me what is the size of one bar. Which size you will use? Number 3, number 4, number 5, maybe number 5. What is the area of number 5? You can get this area and the area of steel, you can figure out what is the number of bars. Remember, your number of bars must be 4 or more. So if this number is 3, no, make it 4 or use smaller size of bars. So your design of column is, the design equation is this one. Maybe this one is given, not given, but all of your steps will be around this equation. Right now, we are designing our column under the effect of axial load only. What will happen if you have axial load and moment at the same time? We will do next time.